Hi, in this tutorial we are going to solve a question related to naming of aldehydes and ketones. The question asks, name the following molecules according to IUPAC rules. Let's start from the first question or from first option. In the first option we have here an aldehyde functional group and an alkene functional group. The reason that we have here an aldehyde because we have a carbonyl functionality here, and we have here, it's not written but we can add, there is a hydrogen and an alkyl, a carbonyl and hydrogen, so this is an aldehyde functionality. So how do we name aldehydes? Basically we have to start numbering from the carbonyl carbon. This is number 1, number 2, number 3, 4, 5. We have to find the longest chain, 6 and 7. We are including here, there is an alkene functionality, the double bond also. So when we have 7, this is heptane, the alkane, corresponding alkane name is heptane, and we have to say that this is heptane. E will drop and it is an aldehyde, and we have to add al suffix here, so this is heptanal. And if we look at here at the fourth carbon, we have an alkene functionality, so instead of heptanal we have to say it is heptinal. Okay, and we have to specify that double bond is at the fourth position, and we can either say it is 4-heptinal. This is the old naming system. The number of functional group is written before the parent name, or according to new naming system we can write this is hept 4 then dash in al. So basically 4 refers to the presence of a carbon double bond, an alkene functional group. So hept4-enal or 4-heptinal, both of them are correct naming. And if we look at here at fifth position we have a methyl substituent, so let's use this one. So we have 5, we have to start with capital letter, 5-methyl 4-heptinal. By default aldehyde carbon is number 1. So the IUPAC name is 5-methyl 4-heptinal. Let's look at the second question. Second question is also an aldehyde, because we have here CHO group. There is carbonyl oxygen and hydrogen. So this is an aldehyde. An aldehyde is next to a ring. So the naming is a little bit different for these kinds of molecules having next to the ring aldehyde functionality. This is cyclopentane. Let's write here cyclopentane, and instead of saying cyclopentanal we say cyclopentane carbaldehyde. So the name of this molecule is cyclopentane carbaldehyde, but we have here two elements in this molecule. We have a methyl substituent, and what is the location of methyl substituent? Let's number the ring. So this is 1, 2, 3, 4, 5. At the second carbon we have a methyl, and at the first carbon we have the aldehyde functionality. So if we'll write here, so let's write the name. So this is let's move this one over here, then let's write let's write 2-methyl cyclopentane carbaldehyde. 2 methyl cyclopentane carbaldehyde. But we have to specify that uh, the aldehyde group and methyl group are on the same side of the ring, and if we say cis 2-methyl cyclopentane carbaldehyde, uh, we might say that aldehyde and methyl groups are on the same side. But what if the aldehyde and methyl groups are going inside the paper plane? That's going to be also cis. So basically, saying cis is not an enough parameter to tell that methyl and aldehyde groups are on the same side. So if we look at first carbon and second carbon, we have 4 different groups. So basically, we have to specify R or S configuration for this question. So let's draw it again here. We have a cyclopentane. Here, and I'm going to do for this one hydrogen and CHO. This is solid CHO. Let's number the groups, then we can assign R or S configuration. So this carbon is number 1. Let's not forget this part also. This is CH3 and this is hydrogen. So this is number 1 carbon. Hydrogen is number 4. This is number 4 hydrogen. This carbon is number 2 and this carbon is number 3. If we look at the rotation from 1 to 3, from 1 to 2 to 3, this is clockwise direction. So this is our configuration. If we draw again the molecule here another time, and we can do the same for the second chiral center. Okay, so let's number again for this chiral center. We know that hydrogen is number 4. This carbon has to be number 1. This carbon has to be number 2. And CH3 carbon is number 3. If we look at the rotation from 1 to 3, so this is counterclockwise, and if it is counterclockwise, this has to be S, and we say that the first one is R and the second one is S. So how are we going to include R and S configuration in the naming? So basically here before 2, in the parentheses, we have to say that the first is R configuration, first carbon 1R, comma, and the second carbon we have to say it's S, so 2S. Then we are going to close the parentheses, then we are going to separate with the rest of name with the dash. So this is 1R, 2S, 2-methyl cyclopentane carbaldehyde. So let's move to the third option. In the third option, we have a ketone functionality, and this is on a cycloalkane. So let's look at how many carbon in the ring we have. Then we can decide what kind of cycloalkane is that. So if we say that this is number 1 carbon, 2, 3, 4, 5, 6, 7. We have 7 carbon in the ring, so this is a cycloheptane. And at the 2 and at the 4th position we have methyl group. So let's write the name 2,4 dimethyl cycloheptanone. So this is a ketone. It has to end with a suffix on. Let's move to last option. In the last option we have again ketone, but we have ketone in two places, so we have to number them. So we have to start from the end nearer to first ketone. 1 2 3 4 5 6. So it's an hexane, and at the 2 and 4 positions we have ketones. So we can say that this is 2,4 hexadione. It's a ketone on, and we have two ketones, we have to say dione. Okay, let's review again what we have done. We named four molecules. In the first case, we had an aldehyde, an alkene, and the longest chain was 7, so it was heptane, and it was heptenal, and we included the position of double bond before the parent for heptenal, and at the 5 position we have methyl. And also we can add one more element to this naming. Since we have a double bond here and alkene functionality, we can either say cis trans if applicable, or E or Z. So let's look at here. We have double bond, and this double bond has 3 substituents. So this is hydrogen, there is 1 hydrogen and 3 substituents, so we can call E or Z. Let's look at the priorities. This ethyl group has more priority than methyl group here, and on this side there is a carbon here, a hydrogen and a big alkyl group, so this alkyl group has high priority. So high priorities are on the same phase, so we can say that this is a Z alkene. So if we add here Z, or you can say it's 4Z, because the position is 4. And in the second one, it was an aldehyde. Aldehyde was next to ring, so for that reason we say cycloalkane carbaldehyde, and we included the configuration of first and second carbon, and also we included the position of this substituent. The third one was a cycloalkane ketone, so we said cycloalkane on, cycloheptanone, and we specified the locations of substituent. And the last one was a ketone, a diketone. So we specified the position of carbonyl oxygens 2 and 4, and the longest chain is 6. This is hexane. So we said 2,4 hexadione. Thank you so much for watching.